Hello and welcome back. In this sub-lesson, we are going to see how to deploy BGP route reflectors. Switching back to our demo topology, we have AS65000 in which NXRR node is acting as the route reflector. Now let's see the behavior, and remember we established a BGP peering between NX1 and NXRR, but we did not define NX1 as the route reflector client. Let's see what is the implication of that is. Now if you look at NX1 and look at its BGP table, we'll see show BGP IPv4 unicast, and we can only see our own prefix. Whereas if we go to NXRR, so before I go to NXRR, let me clear the screen, okay? So I'll go from NX1 to NXRR. So if we go to NXRR and we look at the BGP table, show BGP IPv4 unicast, we can see that it has a lot more routes than NX1. It has NX1 prefix, it has NX2 prefix, NX3 prefix. Logically, all of these prefixes should be present on NX1, but it is not. Why? Because right now, there is no route reflector configuration present on it. So if we look at show run BGP, we have removed, previously there was route reflector configuration for these neighbors, but it is not there anymore. And there was no route reflector client configured for 192.168.1.1 as well. So let's go under the configuration mode and see what configurations we need to make to enable BGP route reflector. So router BGP 65000 and say neighbor 192.168.1.1, address family IPv4 unicast, and say route reflector client. And then we can do the same thing on neighbor 192.168.2.2, address family IPv4 unicast, and say route reflector client. Neighbor 192.168.3.3, address family IPv4 unicast, route reflector client. So with this change, let's look at the BGP table again on NX1. And there it is. So now we have the BGP table updated with NX2 prefix loopback and NX3 loopback. And if we look at show BGP IPv4 unicast 192.168.2.2, we can see that it is being reflected by the route reflector 192.168.10.10.